Welcome, everybody. We're going to work on our chapter 9 exercises tonight. The topic for the night is objects and classes. And here's our first exercise, exercise 9.4. It says, implement a class address. An address has a house number, a street, an optional apartment number, a city, a state, and a postal code. Define the constructor such that an object can be created in one of two ways, with an apartment number or without. Supply a print method that prints the address with the street on one line and the city, state, and postal code on the next line. Supply a method called comes before that takes two parameters, self and other, that tests whether this address comes before the other when compared by postal code. All right. So where we start with this, right, is because we're going to implement a class, we first have to build the class. So we need the blueprint before we can build anything else. That's kind of the point of this. So this is where we are going to begin. So back in Spider, I'm going to do a save as here. And I don't think I created a folder yet, but I'm about to do that. So I'm navigating to my storage location here. And this is 2024 fall semester. I'm making a new folder for unit 9. All the work will go in there. This is, well, actually, okay, so now we got to talk about this. Normally I've been naming my stuff exercise, whatever. But now we're dealing with class files. Okay, so this is where it gets a little weird. A class file will be created as its own standalone file, and then the objects that we instantiate from the class file will be separate or will happen in a different file. So I'm going to create a standalone file called the name of the class, and I want you to notice that I am going to name it exactly what they call the class. I'm going to call it address.py. Okay. I'm going to go ahead and save it. I'm also going to remove all the pre-existing junk here that Spider throws in. I'm going to zoom in just a tad, zoom in on the console so we're ready to see it, basically. And the first thing I'm going to do is I'm going to put a little definition up at the top and just say, describe. So if anybody looks at this file, I'm explaining what it is. Address class for use on homes with or without apartment numbers. Okay. Then we're going to go down a line or two. I'm going to use the class identifier. So I'm going to say keyword class. And now I'm going to name my class. And I want you to be mindful here. The convention is class names start with a capital letter, not a rule, a convention, right? Followed by a colon. That way, when we look at it in code, we can spot that it's a class because, oh, it's a capital letter. It must be a class, right? So that's kind of interesting. Now, the next thing that we're going to do here is we're going to build, I'm going to go down a line or two. You notice that I'm indented, right? So everything that's inside the class is going to be indented from the margin. And the first thing that we have to create is what we call the init function or the constructor function. The comparison I made like during the Kahoot that we did is that when you do a language like Java or C# and you add data fields to a class, you usually list them at the top and then start writing your constructors and methods. That's not how we do it in Python. In Python, what we do is we put all of that into the constructor function that's called the init function. So here's how we do it. We say def, now mindful here, 2 underscores, not 1, 2 underscores, no spaces, init, and 2 underscores, followed by parentheses and then a colon. And then the stuff that we will define will go inside here. Now, there's a convention that we also do when we're doing class structures, and this is kind of similar to when we were building functions. So I'm going to throw this in. You don't have to throw this in, by the way, right? But often when people are building class files, because it's a blueprint and somebody looks inside of it, they want to explain what's going on. So I'm explaining here that the init function constructs an address with or without an apartment number. And notice all the different parameters, and I haven't added those yet, but those are all my data fields. So all those pieces of information will become a data repository, if you will, inside this object or the subsequent objects we create. Here in the parameter list, right, and that's what's implied from the text above, we're going to include self. Okay, so let me talk about that. every Python class object, when we're doing a method, must have this at the beginning as the first parameter, even if no other parameters are passed in. That's required. Why? I really don't understand the engineering behind it, but that's just how they do it in Python. And that's all I'm going to say about it. They require it is there because when ultimately we are building it, what are we building? We're building itself, I guess. Now I'm going to add the parameter list as we see above. So I'm going to add house, street, city, state, postal. And some of you might say, don't you want to put the address after the street? No, I'm going to put it at the end and I'll show you why. And then with that one, because the apartment is optional, we do this. So I'm sending in a value with an empty string. So if somebody doesn't send that in, it's going in as an empty string. So it's pre-initialized basically. But if I send a value in, it will take a place of that empty string. All right. Once we're inside the init method, the convention for Python, we talked about this in the Kahoot too, for what we call self-referring variables is we use that keyword self, right? So with every internal variable, right, we're going to name it. And then, so what I could do is I could name house. Okay, that's a little weird. Okay, and what they really mean here, this is the house number. And so this is how I would kind of do it in like Java, but like in Java, I would say this dot house, right? But the convention in Python is we use self, and to show that it's an internal data field, we use a underscore in front of it. So we say self dot underscore house. And then it's going to be receiving the house number externally. So that number will come in and it'll get stored in that internal variable, self dot underscore house. And now we're just going to repeat this process. Okay, so for the sake of efficiency, right? You guys already know where I'm going with this, right? Here's the whole thing. If you guys want to save the typing, this is the value of showing up to class, by the way. So not a lot of excuses for not getting it right, basically. But we'll do that with all the other parameters. Now, notice in the list here, I put apartment where I think it should fit. So house number, street, apartment. So it's kind of like 123 Elm Street, apartment 5. It's kind of the thinking. Then city, state, and postal code. All right. So to build the object, we have to send all those values in. All right. So that's the initialization function. Next, it wants us to build a function that prints an address, right? So I'm just going to label it, right? This one doesn't receive any parameters. I don't have to send anything in because the data is going to be built into the object. I'm just trying to output it, right? So I'm going to define a function called print address. And once again, I'm not sending anything in, but I always have to include that self thing when I do objects and classes. It's required in Python. And once again, I really don't know the exact reason why. I'm sure I can look it up though, right? And then what are we going to print? Well, first we're going to print on the first line, we're going to print the house number. So we're going to say self dot underscore, and you see I did a dash instead. And I'm going to choose H, and hopefully it finds house, so I don't have to type it. And the street or the street that follows too. So we're going to put the house number like 123 and then the street name. So we'll say self dot underscore street. That's the first line. 123 Elm Street. All right. Then we have this apartment number thing, but we're only going to print it if it shows up, right? So then we're going to do an if statement. So I'm going to say if self dot underscore apartment does not equal an empty string. So if it has something in it, in other words, then I will print apartment number, and then I will append to it the apartment number that was provided. So self dot underscore apt, but only print it if it's provided. Back one indent level. Then we're going to output the city, state, self, and postal. And for those that need it, kind of like that hurry up offense, right? One more method we're supposed to build inside here. And then just like a little comment about that, right? The terminology. When we build a regular program and we build a function, we call it a function, right? And we use the def keyword to define a function. But when it's inside of a blueprint or class file and it's attached to an object, so it's embedded in something, then we call it a method, right? So that's the terminology. So this one's going to determine if one address comes before another. And we're going to do this in really very quick fashion here. It's just a very short bit of code, right? So we're going to feed into it a different address object. So the parameter we're going to pass in is another object with all those data fields and all those capabilities. And then we're going to compare if this one, the self postal object, right, the zip code, comes before the other. So notice the less than. So in other words, if I live in Boston, my zip code might be like 01123. And if I live in California, my zip code is 99543, right? I don't know if you guys know that about the US, but the low numbered zip codes start in the Northeast. And as you go west and south, they increase, I think is how it goes. Or maybe they increase as you go north. I'm not sure. But the zeros are on the West Coast. The zeros are on the East Coast. The nines are on the West Coast. Wisconsin's in the middle. So all our zip codes start with 5. Now, really crazy story. I have a friend that's worked at the post office his whole life. And he's one of those guys that when people don't put the zip code on the letter correctly, he looks at it and types the right zip code in so it ends up in the right place. He's got all of them memorized, you guys. I'm blown away. Right? It's a byproduct of the job. If you did it for 30 plus years, you'd probably memorize them all too. But it is a system, and I think that's pretty fascinating. Okay, so this is the class file. We're going to do Control S to save. Okay, so I'm just going to do this once. This is a non-executing file. It does not execute. When I hit play, it did nothing. Why? Well, because it's not supposed to. This is a blueprint. It's not a house. You get it? Right? This is the description of how to build the object, not the object itself. All right. So to test this, now we got to write a program to test the address. And the pattern that we typically do in this class, and you can call this really whatever you want, but I'm going to call it demo address. Okay. Put it in the same folder. And then we're going to do something that's we've done a few times, but not quite enough, I think, right? Is the first thing that we're going to do is in order to use that class file, it's an outside resource. It's like an outside library, basically, or an outside data type, if you will, a custom data type. Some people will call class files. But we're going to import the class file, but it has to be in the same directory. So from the file called address, we are importing the address class. That's the thing. And as I import it, all of its capabilities are present and available to me to utilize, right? So we need to basically instantiate or construct some objects. So this is what will come next. So this is our task. We're going to construct 2 addresses in this sequence. And so in other words, you want to use your own data here if you can, but I'm going to use this. So I have my house, right? It's not really my house, but the address is 1313. That's a number, right? Mockingbird Lane. Does anybody know where that comes from? If you guess the Munsters, you are correct, right? It's kind of a fleeting thing now, right? But back when I was a kid, that was the thing. And then we have Racine, Wisconsin, and the zip code. Notice no apartment number. right? So that last parameter will automatically set itself to blank and therefore not be included in the object. But we also want to try it with the apartment number. So I'm creating another object called your place. Now, here's what makes it an object, right? The fact that we're calling the address class, I know I'm calling a class because of the capital letter convention, right? That the fact that we have parentheses indicates that we're calling the constructor function. That constructor function receives all of those parameters. Self is self-referring, it has to be there, but we don't have to feed it in. All of those values will land over here and then populate all the data objects. The object is then created with all that data, and that object becomes unique, and that data travels with it. Okay, so that's kind of the conception, right? So I made one without an apartment number and one with an apartment number. Okay, my house, your place. All right. All right, now we got to demonstrate it working. So this constructs it, but still we have nothing to look at. Okay, so how do we know that it worked? Okay, well, this is where, okay, and I'm going to just drop all this code in, and you guys can tell I want to try to do it as fast as I can here. So I'm going to do the same thing. So I'm going to demo this. So these two lines construct the objects. I got two objects, one called my house, one called your place. Now, if I say print my house address is, right? So I will call upon my house, and I'm calling upon the print address method built into it. It's built into the object. What will that do? It will print the address in that logic that we already set up, right? So I don't have to write all that like fancy print stuff. Isn't that cool? It's built into the object. I just say, okay, print it. And there it is on the screen. Then we're going to print your place. And then we'll run the comes before. And this is the one that's really the powerful one that you might not pick up on right away. But instead of passing in like an integer or a string or something like that, or even a list or something, now we're passing in a whole object. That whole object travels with all of its data fields and its capabilities. And really what I'm looking at inside that object is just a postal code. I'm comparing my postal code to the other person's postal code and which one is greater. And does my house come before your place? Answer the question first. The answer is yes, right? Because 53003 comes before 53140, whatever. I don't know if those are even real zip codes. I know that downtown is 53403 or something like that, where campus is. All right, here comes the run. All right, so my house is, your address is, notice the apartment number included. And does my zip code come before your zip code? True. That's the result of that. So it checks greater than or less than and returns either true or false. You want to test that last one? You can change the zip code to something else, run it again, and then notice. Yeah, I want you to notice the message it threw in the console too. It says reloaded module address. So the objects that we had created only existed while the program was running, which was like 1 second. And then they're gone from memory, by the way. That's the example on that one. Moving on to the next exercise. Next exercise is, I don't remember the exercise numbers, 9596. Okay, so we're going to 95. And this one says implement a class soda can with methods get surface area and get volume. In the constructor, supply the height and radius of the can. Okay, let's just take a thought about this for a second. This is really vague, correct? Yeah, it is a very vague description for an assignment. However, we're going to build a class called soda can. And what features does a soda can have? They have a little picture of one. Well, think about how a soda can is. What are its features? Well, its features are it has a height, it has a diameter, right? Because it's circular. And and it says, what are we supplying? The height and the radius. Okay. Well, the diameter is twice the radius. Right. And then we are told to build two methods, get surface area and get volume. These sound like calculations. Okay. So here's what you do. If you don't know the formulas, because nobody does, by the way, I could say the volume of a cylinder, and there's the formula, folks. Right? Don't have to invent it. I can just Google it, ask Chat GPT or whatever. It'll tell you the same thing. And then the other one was the surface area of a cylinder. Now, you notice once again what we're dealing with. We're dealing with both formulas have the radius and the height built in, right? And we're told to feed those pieces of information in. There's different formulas though. This one includes pi. What was that number again? 3.1415, whatever. So I could hard code that, but we could pull in the math library also, right? We're also squaring the radius here, so we're gonna have to use that exponent thing, and the same here. But you got to get the formulas right. Right. Here's the other nice thing, because Google just like puts it into the browser like this, I can test the values by typing them in here to see if they're right. See if my stuff is working correctly. All right, let's start by building the class file or the blueprint. So new program, and this one we're going to call soda can. All right, so I'm going to do a save as, and all lowercase here, soda underscore can, right? That, and you could get rid of the underscore, whatever, it doesn't matter what you call it, just remember what you're calling it, right? Getting rid of the superfluous stuff at the top, and then I'm going to put in my little pre-configured little descriptor here, right? Now I want you to identify, because the instructions are vague. Okay. And I'll say that kind of a little bit against the author. I wish they would have given us a couple more sentences, but notice that these calculations or the formulas that we're going to throw in are part of the class. They're not going to happen in the program file, right? Think about this for a second. So if we're going to do math, and we're going to do math with pi, I better import that into my class. So this is kind of a important takeaway too. So like the way that I was importing stuff into a file to run the class, I also have to import from the math library. I'm going to import pi so I can just refer to it rather than have to type out the 3.1415926, whatever it goes from there, right? Yeah. So I'm just importing it. And then from here on in, whenever I want to include pi in a calculation, I just say pi and I'm done, right? Another way you could handle it, real frankly, is you could just create a variable called pi and put the value in, whatever. I think this is a better approach. We're going to build a class. We're going to call it soda can. Notice the naming convention, capital S, capital C. Starts with a capital, implies that it is a class file. We need an init function, right? Double underscore, and then we need our parens. We always have to include the self-referring variable. We were also told that in the constructor, we should include the height and the radius. And I'm going to put them in with their full names, right? And then a colon at the end. And now we need to apply those to the internal data fields that are basically named the same. So we're going to use the convention that we learned, self._height equals the height that's being fed in, and self._radius equals the radius. All right. I'm expecting you guys to type that one in by yourself, but I will copy paste the rest of them. The next one that we're going to do here, and I'm going to paste these in one at a time. And here's in the chat. The first method we were told to build was to get the surface area. I went out to Google. I looked up the formula. I copied it in here. And you notice what I did is I went right to the browser and I just copy pasted it. And it even copied the pi character Unfortunately, it doesn't work in code, but I have it there as a reference to look at so I can build my code correctly. And I could take the formula, store it in a variable, and then output the variable or return the variable, but I can just go directly to the return statement too. And the parentheses are important here, which is why like Google shows that in the browser. Well, I guess they don't, but the order of operations would handle that, right? Because we wouldn't add those two characters first. We would do all the multiplication and exponents, and then add them together, right? To enforce it in code, I'm putting parentheses around each part of it. That just helps me. But I'm taking 2 times pi times the radius times the height plus 2 times pi times the radius squared. And that gives me the surface area of the can. All right. The next one is to get the volume. With the volume, also brought the formula in. That one's a little simpler. It's pi r squared h, right? R squared, yeah, it is r squared. All right, so, and then I'm just doing a direct return statement. They're all multiplication, no parentheses are needed. So pi times radius squared times height. Now notice I don't have a print method in here, right? So that doesn't do any of the printing, it just returns the values. So I'm going to create the object, feeding in a height and a radius. Then I can get their surface area and their volume. All right, so let's save this file. Once again, this is a non-executing file, so we have to write a demo program to make it do something. So creating a new file, doing a save as, and we'll call this demo soda can. We get rid of the stuff at the top. All right, so like we did with the last one, first we have to import our class file and the class that we want. Now we need to create 2 cans. Okay, so here's the creation. I got can 1, that's 20 high and 5 for radius. I don't know if it's inches, feet, millimeters, yards. It doesn't really matter, right? Let's just assume it's meters or something. I don't know. If it's a soda can, it's probably millimeters. Second one is 30 tall and a radius of 10. Okay, so I created 2 objects, one called can 1, one called can 2. Now we're going to do kind of a goofy little thing here. And I wouldn't necessarily do it this way, but I'm creating a variable called SA for surface area. And for can 1, I'm getting the surface area. So, okay, so why am I putting it in a variable? Because when I call get surface area, it's returning a value. That value needs somewhere to go before I output it to the screen, right? Now, I could just do a direct print statement too. So that's a way to do it as well. But the way I opted to do it is I would just create the variables. So I'm getting can 1's surface area and getting can 1's volume also. Then I'm going to output it. Now, there's a little bit of strategy as to why I feed it into a variable, right? So I can do that with can 1, right? And then all I have to really do is tweak the code a little bit to refer to can 2. I use the same variables, tweak my output statements ever so slightly, and it will work. And I know you guys are like in a panic trying to type as fast as I'm copy pasting. There's one, you should be able to extrapolate the other from that, right? Hopefully you type this stuff in. Type that stuff in, take the one I copy pasted, tweak it, and make it the other. All right. I'm going to go ahead and save this, and I am going to run it just to show you. So can 1 surface area is 785 whatever, and the volume is 15 whatever. How do I know that's true? I can take 20 and 5 and put them into Google. So we want this is the surface area. So 20 and 5. And is that correct? Surface, no, it's not. Okay, can one surface area is 785. All right, so something's going wrong here. Or am I not looking at the right surface area of a cylinder? The volume of a cylinder. Now I'm checking my math setup. So the volume, all right, let's try this one. 20. Oh, I see what's wrong. I'm putting the wrong numbers in the wrong places. The radius is 5 and the height is 20. All right. Okay, now the number matches. All right, but see, you got to read the instructions, I guess. All right, now the numbers are right. See how it matches up? Attention to detail, folks. If only I would have did it the first time. But it's kind of nice to be able to check it. All right, I'm moving on to the next one. And I know I'm going quick, but is everybody getting it to work? All right, moving on to 9.6. All right, this is kind of an interesting one. And this will kind of remind you a little bit of like a program we wrote a while back. I don't know if you guys remember it, where we like sort of did the same functions, but we didn't do it with classes. We just kind of did it and did the same calculations, but we did them with functions, right? So this is kind of an extrapolation of that one. And this one says implement a class car with the following properties. A car has a certain fuel efficiency measured in miles per gallon and a certain amount of fuel in the tank, and the efficiency is specified in the constructor, and the initial fuel level is 0. So when you get the car, it's empty. Supply a method called drive that simulates driving the car for a certain distance, reducing the fuel level in the gas tank, right? So if you get 10 miles to the gallon and you drive 10 miles, you've used that gallon, right? That's kind of the point. And then methods to get the gas level so we can see how much gas is left, and to return the current fuel level and add gas to tank up. So sample usage, right? So let's show you some code that you can throw in to test it once you've built it correctly. So we'll have a car class, and all we're going to throw in is the miles per gallon. Then we're going to add gas to it, and then we're going to drive at 100 miles, and then we're going to see how much gas is left. That's kind of the thing here, right? And this makes our main program really, really clean, and all the difficult stuff is hidden in the class file. Okay, let's build the class. Back over to the spider, and we'll create a new file. And we're going to build a car class, so let's call the file car. So I'm going to do a save as here, and we're just going to call it car. Good enough, right? It's a car. All right. We don't need to import anything for this one, so we're just going to go ahead and start by calling it class car, capital C, right? And then we're going to define our init function. So double underscore, space, double underscore, init, double underscore, and parens and a colon. Inside the parens, we must have the self-referring parameter. And then we are going to throw in only one thing, just the fuel efficiency. That's the only thing worth feeding in. We're going to take that value and apply it to an internal data field. We're going to call it self._fuel efficiency. And this has kind of been our pattern all along, right? Right, so the parameter gets assigned. And there's another parameter that we're not feeding in, but when we create the object, we were told that the gas level should be preset to 0. I'm just going to call it gas, but it implies how many gallons are left. Okay, that's the init function. That one I expect to type in yourself. All right, now we need 3 methods. Okay, the first method is, well, we got to put some gas in the car. So it's empty, comes empty, right? So we're going to have one called add gas inside self-referring. And then how much gas are we adding? So we'll just call it, not caps, sorry, amount. And then all that will do is take that internal gas thing and we're going to plus equals to it or add whatever the amount is. So whatever gas we're adding it to the gas tank. All right. That's method number 1. Yeah, I see you guys watching the chat. Yeah, there it is. There it is. That's my Christmas gift to you, I guess. All right. Next function that we're going to build is the drive method. And this is the one that uses the gas. Once again, inside the parens, the self-referring, which is required. And then when you drive, what determines how much gas you're using? Well, we know what the fuel efficiency is. What determines it really is your distance, right? And, I always tell my students, when you own a car, you should know what your range is with that car, especially when traveling out west in the desert or really remote areas. And you see a sign that says next gas 200 miles, you should pay attention and make sure you fuel up, by the way. All right. So how would this one work? Well, we're going to change the gas level ultimately. So self.gas is going to be equal to self.gas minus, in parens here, the distance divided by the fuel efficiency, right? Miles per gallon, right? But this is how you determine that. So if I drive 100 miles, right, and my fuel efficiency is 20 miles per gallon, how many gallons am I using? Well, 5. And then I'm going to subtract that from the gas in the tank, and that's how much gas I have left. Right? See the idea there? Next, we need to define a get gas level. And I'm going to say this probably just once here because we have our semester is rapidly closing here. We got 20 minutes left of the semester, basically. But this naming convention, right? So like usually when you work with most object-oriented programming languages, when you create data fields, you can set the values for the data fields and retrieve the values for the data fields. And you usually do that with methods. And when you're setting a value, you call that a setter, right? And if you're returning the value, you call it a getter, right? And so like in Java and C#, we call them set and get, or setters and getters. And there's other words for them too, but those are the main ones that we use in those languages. But the convention of returning just the value, that's why we call it get gas level. It just implies that we're returning a value, right? So very, very common in object-oriented programming. We just go right to the return statement on this. We don't need to do calculations. The gas level will be whatever it is that it is. We're just returning it so people can see what it is. The car class is done, right? That one I'm hoping you can type in yourself. Do it really, really fast. And then I will write the demo program. Now we need to do a demo to test it, right? Because we can't run this. We've learned that. And this one, we're going to call it demo car. So demo car. I'm going to get rid of this junk and zoom in. All right. Once again, we're using an external file, so we got to import it. So from the file called car, import the car class. That's really what you're doing there. We're gonna, let's see. I think we'll follow exactly what the book did. So this is what the book did. I just copied their code verbatim. Right, I think I copied it verbatim. Maybe I should check really quick. No, that's not verbatim. Okay, well, never mind then. Right, but if you want, you could copy this code too, and try it. But here's my first object I'm creating. It's in the chat. So I'm creating my hybrid. Right? And this is pretty typical for a hybrid car. They get about 35 miles to the gallon for, a normal kind of car. So we'll add 15 gallons of gas. That's a pretty normal tank size too, by the way. And then we'll drive 100 miles and how much gas is left. That's what this will do. All right, let's run it. We can run it just the way it is. I'm getting a little error here. Undefined name car. Oh, duh. Okay,
I
here's why.
capitalized. Yeah.
Yeah. Thank you for catching it, right? But hey, that's why we have an on the fly debugger. I'm going to go ahead and run this. And then you will notice that after I drive 100 miles in that car, I have 12.14 gallons loaded. This is kind of interesting. Why is it reloading module soda can? I have no idea. That's really weird. All right. Is this the correct answer? Now it makes me kind of wonder. Matthew, you got a question?
Yeah, so when I'm in the class car, I wrote out everything that we have. Oh, I think I see it now.
Okay. There's got to be probably a syntax thing.
I was missing the self on line 10.
Yeah. Right. Because, this is one that's coming in externally. This is the internal one. And remember, you don't have to name it this. This is kind of the interesting part of this. I could really just call it fuel efficiency, just like the incoming variable. Or what a lot of Python programmers also do is they just call it this. This is the safe approach. It ensures that it's attaching to the internal. Right.
Okay.
Not a rule, a convention. Right. There are reasons why you do have to use it. This is not one of them, by the way. All right. So now that we have that one, I always like to do this. So, for example, I have a few different vehicles, right? So I also own an old van, old Volkswagen van, if you're curious. It's got a very small motor, but it's not a very fuel efficient, right? But it runs. It's like a 40-year-old vehicle and it still runs, right? And this is the mileage I get. I get 15 miles to the gallon. I have a problem with my gas tank. It's got a hole in it. So if I overfill it, it spills out. So I never fill it past, that like a certain level. This is really kind of goofy stuff to share. And then I also I don't have a gas gauge that works, nor a tachometer that works. So I can figure out how many miles I drove. This is really kind of an interesting thing. So I actually went out to the internet, found an app. So whenever I'm driving it, I turn on this app, it tracks how many miles I go. And then I make sure I don't go too far before I put gas in, right? Because I don't know how much gas I ever have in the car. It's kind of a scary thought, but I always gas up every time I drive it. Basically, it's kind of what I do. But let's run that one and see. So if I drive 100 miles in that van, right? I added 16 gallons of gas. I drove 100 miles. How much do I have left? Only 9 gallons. Ooh. It's not very fuel efficient, right? There was a time that was actually considered fuel efficient, believe it or not, because we used to drive cars that would get like 7, 8, 10 miles to the gallon, like, big like Oldsmobiles and stuff with like V8s and highly inefficient motors. What I do find interesting is I do have one car, and I know I always use it as an example. It has now died on me, and I have not put money into fixing it yet. I'm contemplating doing it, but I have a Volkswagen TDI that's diesel and manual, and it's hacked, and I average at least 46 miles to the gallon. This is city, folks. Put me on the freeway, and it's like 52, right? It's a 13-gallon tank. And then if I drive 100 miles, I still have 10 gallons left. That thing is got a crazy range. I can do 600 miles plus on 13 gallons. Right. I don't know why they never figured out hybrid diesel. Now, with that, you could probably hit 100 miles to the gallon. Right. I don't know why they don't do it. Diesel is kind of a dirty technology, but they have technology now where it runs really clean. But Volkswagen had Dieselgate, and there you go. That's off the table, right? They're trying to make us all electric. I have my reservations as to whether or not that will be efficient, or not. I think the future is more hybrid for a while than all electric. That's just my speculation. And I guess my commentary, if you will. All right, one more exercise. The last exercise, oh gosh, what's the number on it? 910.
A quick question, Ty. I'm getting a
Yes, Juan.
car takes no arguments error.
Oh, okay. One, go to your class file and make sure that you have this in the init function. If you do, if your init function looks like that, you have those two parameters. The next thing to check is check how you said init. Is it 2 underscores, no spaces
Oh,
in it?
that's what I missed at 2 underscores. Okay, perfect.
That's a very normal mistake to make, by the way. And glad that you spoke up about it, because it's because you can look at your code for hours and go, I don't see it. I don't see it. And it's
Yeah.
right there. Yeah.
So thank you.
Ask me how I know that, because that's how I started with Python too. It's like, I don't get it. Where is it? Oh, that's 2 underscores. Right. Yeah, if you want to have fun with this, it's kind of a goofy little program, but it just shows you like all the stuff we did in that other program where we had to write the functions to do this. Well, once it's built into the object, now all we have to do is create the object, call upon it, and just get the data. See why object oriented is powerful? Yeah, it's very powerful. All right, so with this last one, this is a fun little exercise. I'm going to say it's somewhat timely, right? So it says implement a voting machine class that can be used for a simple election. Have methods to clear the machine state, to vote for a Democrat, to vote for a Republican, and to get the tallies for both parties. All right. Well, we all know how it turned out, but we can still write this program either way. So we will start by building a class called voting machine. So new file, save as, and I'm just calling it voting underscore machine. All right, saving it. Get rid of that junk up there and zooming in. And let's get our class definition first. So class, capital V, by the way, voting machine, capital V, capital M, and then right to the init function. Double underscore. And then self. Right. Now, we were not told to feed in any parameters. Okay, I want you to think about this. We're going to create a voting machine. We don't want to like pre-feed it votes for Democrat or Republican, right? We just want to create it and it's ready to roll, right? Now, when we create it, we want the votes to be set to 0, right? Right. Okay, so we're going to create 2 self-referring variables. One is going to be called underscore the Democratic count, and we're going to preset that to 0. Right, so that's going to happen right when we create it. We'll do the same thing with we'll call it rep count, so Republican count, also preset to 0. All right, so then we have to have methods for people to vote, right? So every time somebody votes Democrat, and then every time somebody votes Republican, we will have methods that handle those. So we will cast a vote. We'll vote Democrat. What does it do? It adds 1 to the total. We vote Republican, also adds 1 to the total. That's all it does. Just adds 1 to the total. Then, we're accumulating a total, right? Every time somebody votes. So then we need to have a way to take those things and show them like what the results are. So in other words, we're going to create a get tallies, thing, and it's just going to return. I want you to notice, what format is this coming back as? Like a final exam question here. Yeah. Notice it's inside parentheses. What structure is that? It's a tuple. And if I'm sending back voting results, why do I want to send back a tuple? because it's immutable. It cannot be changed. So when somebody asks for what the vote total is, they can't change it. They just get to see it, right? So this is kind of clever, right? This is a little bit of learning wrapped in there, I guess. Because if I made it a list, then somebody could write some code to hack that list. But if I return a tuple, it's an immutable object. It just returns the value and you're done. So that's kind of a side teaching note there, but there is a logic for it. We're also told, okay, well, we used this for one election. We don't want to throw the machine away. Let's use it for another election, right? So we're going to need a reset method. I'll just throw that one in the chat, by the way. And then the reset method just takes the counts and puts them back to 0 so we can start over again. Okay, cool. Here's kind of a thought, right? And you guys might not see this. Advanced programmers will see this eventually. I go like, hold on a second. This code is the same as that code, right? It's identical. So let me just comment these out. I'm going to put a pound sign in front of each one of them. So when I initialize the object, could I not just call the reset function that's inside of the object? So I can call itself, call reset. You got to spell it right though, with parentheses, and it does the same thing. Isn't that clever? Right? So, okay. Yeah. So instead of setting the data fields here, I'm setting them down here. It doesn't matter. Right? It's doing the same action. It's sure a lot less code. So when I create a new object, it resets automatically. It starts at 0. All right. That's the class file, folks. Now we need the demo program. So we're almost done here. Almost. All right. This one I will do a save as. And what did I call it last time? Demo vote. Or I could call it rig the election, something like that. I'm kidding. I'm kidding. I'm trying to be lighthearted about it. You know, some people are happy with the election results, some people were not, and whatever. This is still America. At least we have some hope for the future. You know, we do need to do our import. Here's the import statement. So from the voting machine file, we're importing the voting machine class. I don't need multiple voting machines. I'm just going to create one. I'm going to abbreviate it and I'm going to call it VM. And the thing that I'm doing here, and this is a little bit of a precursor, you know, for data students in particular who get a lot more Python coding than most. It's very, very common in Python to take more complicated structures and abbreviate their names into like acronyms, right? You know, and this is just like a preliminary example. All right, so whenever I'm talking about the voting machine, I don't have to like spell out voting machine or whatever, or fall 2024 voting machine. VM is fine. I get it. You know what I mean? So it's kind of like aliasing it or just making it simple. All right, so this part of it is really pretty simple. Next, we're going to cast some votes. So oh, there's the reset thing. I never sent it. I apologize. I'm sure you guys typed it already. But here's some votes. So I'm going to cast 7 votes. You guys are trying to figure out who's he voting for, Democrat or Republican. I switch it up, by the way, in the program. So no, you can't politicize me here. All right. I'm trying to be apolitical. All right. All right. So a bunch of people voted. We only got like, what, 6, 7 votes here, but whatever. But then we're going to show the tallies. Oops, it did not copy. Sorry. And I'm being kind here because of the time. So now we're going to show the tallies, and we're just going to notice we're doing that like drop in place of the wildcards. And we're just going to do get tallies. The values are going to come back. And I want you to remember it's coming back as a tuple. It's sending back 2 values, right? First value goes here. Second value goes there. That's why there's 2 of them as opposed to 1. It's sending back 2 values. And I'm sending them back in that order, right? You can verify that in the class, right? get tallies, Dem, then Republican, right? Dem, then Republican. All right. Let's run it so far, just to show you that it works. So there it is. 4 Democratic vote, 3 Republican vote. Is that correct? That's what I have listed there. All right. That's great. But you know what? Time for a new election. So we're gonna reset the voting machine, and we're gonna print a blank line, reset the machine, all the totals go back to 0, right? Then we're gonna put a message on the screen just saying votes cleared, another blank line, and then we're gonna do a fresh election, right? So this time, this is my voting. We'll just drop those in. That's what I just put in the chat. Fresh set of votes. And then we want to see the results. All we have to do is repeat that statement. I'll just add that to the bottom. Run it again. The first election, votes were cleared. Second election, Democrats won the first time, Republicans won the second time. Okay. Want to do it again? You can do, I mean, now you have the, a way to do it, right? And then, okay, well, what about if you had a different voting machine? Maybe you have multiple voting machines. Okay, so I'm going to reset the original voting machine. So I'm going to do the same reset code. Now, this part of it is optional. The stuff I'm doing from here on down, you do not have to do this, by the way, right? I don't think. It should probably read the exercise thing. Yeah, it doesn't say to do this part. So this is kind of me extrapolating. So I reset the first machine, and then I decided, you know what, let's do votes from a different voting machine. And so what I did, and I'm going to just give you all this code, right? So it's basically the same code again, is I just dropped in all of that. Oh, it did not go in. Sorry. Try it one more time. Oh no, I deleted it in my main file. That's not good. Okay, so let's do a whole bunch more votes. So if I create another voting machine, I just want to show you how it's done, right? I'm just creating voting machine 2. There's a new voting machine right there. And then a whole bunch of votes. And then we'll run the totals again. Right, but it's very, very simple, but at the same time, it's kind of powerful. You know, the simplicity of this program. It really kind of shows how this stuff works. Gave you an example of a few different exercises with different kinds of paradigms and capabilities. This is really just scratching the surface of how these exercises happen and how classes and objects work. But the point is that when you build an object that's complicated and has all these pieces of data, information embedded into them, and capabilities in the form of methods, and they're easy to replicate, basically, then you're just leveraging the object and its built-in capabilities with simple commands. I mean, this is what object-oriented programming is all about. And what we're really doing, in essence, is we're hiding the functionality in a class file. And the main program becomes this. So our class file becomes what we call an API. It's an application programming interface, where all we have to know is what's available inside of it and how to trigger it. And then we never have to write that code. We just utilize the code to do our task. Right. Right. Just to kind of blow your mind a little bit, because we're not going into chapter 10 with inheritance and polymorphism, but I can also create a class file that defines a class file, right? So like one class that inherits from another. And then I can also take classes and objects and move them around like other pieces of data. And often, I mean, this is the power of Python, folks, that here I'm taking this complicated object and storing it in this simple little variable that really is not simple. Right. And then I can throw that around my programs like it's an integer. You know, it's kind of crazy powerful. Now, we built classes and objects that had pretty simple data fields. We had like integers and strings and, you know, simple things like that. But it could also be lists or tuples or dictionaries or sets, or a tuple of lists or a list of dictionaries, or like, or a list of objects. You know, I could go on and on and on about it, but you can build very complicated structures, name them very simple things, and leverage all their capabilities. And then when you start to unlock those keys, you really start to see how object-oriented programming works, right? And then when you go out and you're a real programmer, rarely are you constructing things from scratch. Most often you're leveraging APIs, right? So you're working at conceptually a higher level, but you have this understanding of what's going on behind the scenes. So if you do need to engineer it, you can. All right, I'm going to cap the video here. I know that's a lot to absorb, but the semester has